Hello, this is Paradox class for April 8th. Um, we are continuing with learning about logical connectives. We are taking simple logical statements that are either true or false, putting them together and making new logical statements. Let's get right to it. Okay. All right. So what I'm about to introduce here is probably the most difficult connective that we're going to cover. It's called implication or conditional. So if you've like if you made a sentence that looks like if something then something else, then that's a conditional. In symbols, we use these arrow symbol to indicate one logical statement implies another logical statement. So an example of a statement like that. We need two example statements to put it together. So here's one statement. I have bought Animal Crossing. And another statement might be, I have played Animal Crossing. You can put them together to make a conditional statement. So sentence A arrow B, you could read that as A implies B, or another way to read it would be, if I have bought Animal Crossing, then I have played it. Okay. So the truth value of this statement is a little bit tricky, right? So it's true as long as you don't have a true statement pointing towards a false statement. So you don't want to be able to deduce something that's false when you started with a true statement. So if a true statement points to true statement, so if I have both bought and played Animal Crossing, this statement is still good. A implies B. The only way this statement would be false is if the true is pointing towards false. So this, if I have bought Animal Crossing but had not played it, that would be a false statement. Um, if the Animal Crossing was not bought, so if the first part of that conditional statement is false, that entire sentence still holds as a true statement. So if the Animal Crossing was not bought, it does not matter if I have played it or have not played the game. The statement is still should be true. Yeah. Here's a truth table um, of this implication. So true and true is okay. That's true. The only way it's false is when the true statement points towards a false statement. If the first part of the implication is false, then you just get true. It doesn't really matter what the second part of it's saying. Now, the only thing that matters here is the relationship between true and false, right? You just don't want the true statement to point towards a false statement. So it might be really weird, but the following sentence should be considered true. So if unicorns exist, then China is on the moon, right? So because the first part of the statement, the unicorns exist, is a false statement, you can pretty much say anything you want on the second part of the statement, like China is on the moon. That's definitely false. But false pointing towards a false statement in the implication is considered a true statement. So even though it sounds absolutely bizarre, this statement, the conditional statement, if unicorns exist, then China is on the moon. This is considered a true statement. I think if this kind of bothers you a bit, it might come from the fact that when we usually say if and then statements or conditional, usually you want the two relationship, one to be caused by the other one. But in mathematical logic, it does not matter if they seem or don't seem related. The only thing that matters is this thing here. You just can't have the true statement pointing to false. Otherwise, it is absolutely considered a true statement. It is a little bit tricky. Another part that makes this tricky is that there's in English there's many different ways to say A implies B. So A implies B is one way to say it. If A then B, that's another way to say it. You could also say A only if B, and that means the same thing. And then another trickier way to say it is you flip the B and A, and then say B if A. So it's important to flip the A and B here before you phrase it like that. So all four of these sentences, the meaning of it is that A implies B. The order of where the A and B goes really is crucial here. Okay, so I think, oh yeah, one more connective, biconditional. So in English, you might say if and only if. So in symbols, it's a double-headed arrow. So A and B might point to each other. So if I bring this back to the Animal Crossing example, the sentence A double arrow B, or A if and only if B, could be read, I have bought Animal Crossing if and only if I have played it. Okay. And when you have a biconditional, this thing is considered a true statement if both A and B has the exact same truth value. So they're both true statements or they're both false statements. So if I have bought and played Animal Crossing, then it's considered true. If I have not bought Animal Crossing and I haven't played it, then that's also true. But if one or the other is true and the other one is false, then this is considered false. So if I have bought Animal Crossing and haven't played it, or if I haven't bought it but I have played it, then this is considered a false statement. Okay, and this is the truth table here. So when T and T agrees, it's a true statement. And both F, that's a true statement. If they have the opposite truth value, then it's considered false. Okay, so let's try worksheet 1.5. Let me bring it up here. Okay. So all I have is a list of statements in English, and I want you to interpret like each of these conditional statements, or maybe it's a biconditional statement, and write it in symbolic form. So kind of like a translating that you've done with the other connectives, and, or, and not. So I invite you to pause this video and try it out. And then maybe I'll come back and talk about a couple of the tricky sentences. So go ahead, try it. Okay. Um, so I think the trickiest part of this worksheet is actually the first couple sentences. So let's discuss it. So there's three very similar sentences. So if Mary can find a nice apartment, then she will sell her house. Mary will sell her house if she can find a nice apartment. And Mary will sell her house only if she can find a nice apartment. So all three of those sound very similar, but they don't all mean the exact same thing. So let's name some of these statements. So let's say A is Mary can find a nice apartment. And S is the sentence, Mary will sell her house. Okay, so this sentence is in if then format. So the first part is pointing towards the second part. So here, if she can find a nice apartment, then Mary will sell her house. The second sentence says Mary will sell her house. So first of all, the second if statement was said first. And then in the middle, there's the word if, and then Mary can find a nice apartment. So if, I don't know if you can see it here, but that if you flip the order and then just have the word if in the middle, that's the same thing as this part pointing towards this part. So the second statement actually means the same thing. It's just a different way to say the exact same sentence. Mary will sell her house if she can find a nice apartment. So finding the nice apartment will point towards Mary selling her house. Yeah. This third statement, so you have two statements, sell her house and she can find a nice apartment, but has the word only if in between. So let's see. I don't know if you can see it here. So if you have a sentence only if another sentence, that is equivalent as the first part pointing towards the second part. So the third sentence is actually saying she will sell her house only if she can find a nice apartment. So the meaning of the third sentence is actually different from the first two. That might take a little bit to kind of absorb. So try to see if you can kind of absorb this. There's a different form of sentences you can write in English that's equivalent to P arrow Q or A arrow S in this case. So try to see if you can digest the different forms of the sentences that's made there. And then the other sentences in this worksheet is fairly straightforward. So, well, sell her house if and only if she can find an apartment. So that's a biconditional here. And then the rest, I think, is fairly straightforward. So I think I'll end the video here. I will see you in another video.